Hi. See, we have the hard panel, and we also have the soft panel. These are essentially the same panel, just built differently. And in the middle here is my computer with the power plant simulator, running the simulator. What it does is it takes user input from either panel and produces output. So if buttons were pressed, it'll come up with what needs to happen. Either LED turns on, or a gauge turns on, or goes to a certain value. So we'll go ahead and show you that. You see that these are currently in sync. You can see the green button telling us that it's in sync on this one, and we have a little it says in sync over there as well. So when I turn this on, what's going to happen is it'll update here, and it'll also stay in sync with the soft panel. So you can see that they both work. What just happened is, so I pressed the button. The hard panel sent that information to the soft panel, which updated itself, and then the soft panel sent that input to the power plant simulator. The power plant simulator saw that this first button was pushed, and it came up with output and said turn that LED on. So we'll do the opposite now. It said turn it off because the button's off. Any time a red button is pressed, we program the logic of the power plant simulator to say, oh, red button's pressed, so flash a certain LED. So we'll flash LED 2, LED 24, and you see it also flashes over there. And we have a different little feature here to make it red. Looks good. And just a little extra thing we added to show that we have control over all the LEDs. A little show here. Oops. 3 seconds. There it goes. It's a little nice thing to watch.
Sure you can drive them all.
Yeah. So we'll go ahead and show you the switches. So whenever we program the power plant simulator to see that if a switch is pressed, just turn a gauge to a certain value. We just did 100% and 50%. So every other one will do 100%, 50%. So when I flip this, our gauge goes to 100% here, as well as on the soft panel. And the next one actually goes 50% because it's switched to, and that's what the power plant simulator came up with. So there's our 50% on both panels. So it's very, yeah, if you want to zoom in, I don't know how well that'll.
How to zoom in this.
You see our 100%, 50%, and all that. Let's go back to red. It's better, in my opinion. Okay, so whenever a user decides to change something on the soft panel instead of the hard panel, like I've been doing, the hard panel can't update itself to stay in sync because that'd require a lot more mechanics, and we didn't implement that. So when I press a certain button, let's go ahead and turn this off, it's going to notify us that we're out of sync on both panels. As you can see, the red light over there is on as well. And if the user can't remember why we're out of sync, you can hit this help button here, and it's telling us the following controls are out of sync. Push button 00102. So we'll go over here, put it back in sync, and you see the green button, the green LED turns on, tells us it's in sync. And see, this is now disabled. I don't need help anymore because I'm in sync.
I was going to say, take two things. Make two buttons out of sync.
Oh, sure. I'll show you switches first.
Okay.
So let's go ahead and turn the switch off. You can have a little nice click and drag feature. So now it's off and we're out of sync. Telling us rotary switch 101. So you can go ahead and flip that over there, 101, and we're back in sync.
Very good.
So let's try
Maybe
two.
do a button and a switch.
Sure. Not in sync. Not in sync. So here we go. Push
Okay.
button 101 and rotary switch 101 are out of sync. So we don't have to go over there and turn it. We can just say, oh, I want to turn this back. I didn't want to do that. And there we go. Now just rotary switch 101 is out of sync. So let's go ahead and turn that back in sync. Green and gauge to 100%. So let's just do some various ones here. So we have a bunch of different ones.
As long as that is in focus, will it update the rest of the
I believe so. So that gauge there went to 50%. Now it looks like we are having a little issue right there.
I guess that was an issue.
Okay. Let's put it back. Gauge goes up. That gauge goes up. Gauge goes up. I guess I just picked. Wonder what happened. It must be having some kind of bad connection. But you see that we have a lot of gauges working. So I'll have to see why that one specifically isn't working. We'll leave it on the far side here. See, it works on both of them.
It might have been within assembly. We probably jostled something.
Yeah, maybe something bad.
Yeah.
Any questions?
Do you know all these buttons? It's just some switches in general. So the aim is to switch from the analog to the digital system, right? But do you know which of these objects for what they are working for? Or it's just the switches there? You don't care what these mean?
Oh, yes. So that was kind of out of the scope of our project. We wanted. Go ahead.
We asked them if we should have a purpose for the specific components that we have, like if these buttons should represent a water system or something along those lines. They said that it was, we don't really have the security clearance to be releasing that type of information to us.
This is the tech
So this is,
Yeah.
this
Yeah.
is just a very simple panel that they can apply their knowledge to. And so then they didn't give us a panel to model it off of. We did this ourselves. And then with this, they can use our labeling system to apply purpose for the various components.
Okay. Are you good? Good?